800 soldiers were about to face coordinated enemy attack without communication, air support, or tactical coordination. The satellite system was their lifeline, but repair required climbing 200 meters through conditions that killed experienced climbers. Tech specialist Jackson wasn't a climber, he was just the only person who could save everyone. The wind howled at 80 miles per hour, temperature sat at -20 degrees Fahrenheit, and the damaged tower swayed like a skyscraper in an earthquake. Jackson's repair equipment weighed 30 pounds, the climb would take 45 minutes, and enemy drones were 15 minutes out. Sometimes being the only one who can do the job means doing the impossible. At Forward Operating Base Aurora in the mountainous region of eastern Afghanistan, the satellite communication facility represented the technological lifeline that connected 800 American soldiers to command structures, tactical coordination, and support systems essential for survival in hostile territory where enemy forces maintained significant presence and operational capability. Tech specialist Marcus Jackson served as the senior satellite systems technician with expertise developed through specialized training in military communication systems, electronic warfare countermeasures, and emergency repair procedures that kept vital communication links operational under combat conditions that challenged both human performance and electronic reliability. Jackson possessed 5 years of military communication experience, including advanced certifications in satellite technology, radio frequency systems, and electronic troubleshooting that qualified him for operations where communication failure could result in mission failure and loss of American lives. His technical knowledge extended beyond basic maintenance to include complex system integration and emergency repair procedures. The satellite communication array consisted of multiple redundant systems designed to maintain continuous contact with higher command, coordinate with supporting units, and provide real-time intelligence that enabled tactical decision-making during combat operations. The system's complexity required specialized expertise for maintenance and repair operations that exceeded basic technical training. The communication facility was positioned on elevated terrain that provided optimal satellite reception while requiring a 200-meter transmission tower that housed critical antenna systems, signal amplification equipment, and relay components that enabled long-range communication across vast distances in mountainous terrain that blocked traditional radio signals. Tower maintenance normally required specialized climbing equipment, trained personnel, and favorable weather conditions that enabled safe access to equipment positioned at extreme heights where altitude, weather exposure, and structural limitations created significant safety challenges for maintenance operations. The base's operational security depended entirely on maintaining communication links that enabled coordination with air support, artillery units, medical evacuation services, and command elements that provided tactical guidance during combat operations. Communication failure created vulnerability that enemy forces could exploit through coordinated attacks designed to isolate and destroy American units. Tuesday morning brought routine communication operations as Jackson conducted scheduled maintenance checks on satellite equipment that had functioned reliably despite challenging environmental conditions including temperature extremes, moisture exposure, and electronic interference from enemy jamming attempts designed to disrupt American communication capability. At 0730 hours, enemy forces initiated a sophisticated cyber attack combined with electronic warfare that systematically degraded satellite communication systems throughout the region while preparing for coordinated ground assault that would exploit communication disruption to achieve tactical surprise against isolated American forces. The attack began with jamming signals that interfered with satellite reception, followed by cyber intrusion attempts designed to compromise communication security and gather intelligence about American force disposition and operational planning. Electronic warfare specialists among enemy forces demonstrated advanced capability that exceeded previous threat assessments. Jackson immediately recognized the attack signatures from his training in electronic warfare countermeasures, but the sophistication and coordination of enemy electronic capabilities exceeded defense systems designed to protect against less advanced threats. Multiple communication channels failed simultaneously, creating communication blackout that isolated FOB Aurora from external support. Emergency communication protocols activated backup systems that provided temporary communication capability, but Jackson's assessment revealed that enemy electronic attack had damaged primary satellite components located at the top of the 200-meter transmission tower. Physical repair would be required to restore full communication capability. Weather conditions complicated repair operations as winter storm systems moved into the region with high winds, freezing temperatures, and precipitation that created dangerous climbing conditions at extreme altitudes where exposure and equipment failure could prove fatal for maintenance personnel attempting tower access. Jackson's initial assessment revealed that satellite dish alignment had been disrupted by electronic interference combined with structural vibration from high winds, while signal amplification equipment had suffered component failure that required hands-on repair using specialized tools and replacement parts stored in the tower's equipment housing. At 0800 hours, enemy ground forces were detected moving toward FOB Aurora's position in coordinated formation that suggested planned assault designed to exploit communication disruption and prevent American forces from coordinating defensive operations or calling for air support that could repel enemy attack. Intelligence estimates indicated that enemy forces would reach assault positions within 30 minutes, requiring immediate restoration of satellite communication that could enable defensive coordination and support requests that would determine whether FOB Aurora could survive the approaching battle. Commander Harrison assessed the tactical situation with the analytical precision that characterized his leadership during crisis situations. 20-year military veteran with extensive combat experience, he understood that communication restoration represented the difference between successful defense and catastrophic defeat for 800 American soldiers. Jackson, the commander, said during the emergency briefing, "Enemy attack is imminent, and we need satellite communication restored immediately. What are our options for emergency repair?" Jackson studied weather reports showing 80 miles per hour wind speeds, temperature at -20 degrees Fahrenheit, and structural engineering data indicating that the damaged tower was experiencing dangerous oscillation that made climbing operations extremely hazardous even under optimal conditions. "Sir, the satellite equipment requires physical repair at the 200-meter level. Climbing operations in current weather conditions exceed safety parameters, but automated repair systems are non-functional due to enemy electronic attack. How long would repair operations require?" 45 minutes minimum for access, assessment, and repair, assuming no complications from weather or equipment failure during climbing operations. Commander Harrison examined tactical displays showing enemy force movement patterns and estimated arrival times. "Jackson, enemy forces will be in assault position in 15 minutes. We need communication restored before they can coordinate attack." Jackson understood the tactical mathematics were impossible according to every safety protocol and operational procedure he had ever learned. Climbing a 200-meter tower in hurricane-force winds and sub-zero temperatures exceeded human capability and equipment design specifications, but 800 soldiers would die without communication coordination. "Sir, I'm requesting permission to attempt emergency tower repair despite weather conditions." "Jackson, you're not trained for technical climbing, you don't have proper equipment for extreme weather operations, and tower conditions are beyond safe climbing parameters. This mission is essentially suicidal." Jackson looked at the tactical display showing 800 American soldiers who would face enemy attack without communication, air support, or tactical coordination that could enable survival. The satellite system represented their only lifeline to survival, and he was the only person with technical knowledge to restore communication capability. "Sir, those soldiers are counting on someone refusing to accept impossible when their lives depend on communication restoration." Jackson assembled climbing equipment designed for tower maintenance rather than extreme weather operations, understanding that his improvised approach would require adaptation and innovation throughout the climb where standard procedures might prove inadequate for survival at extreme altitude in dangerous conditions. Military climbing harness rated for tower work provided basic safety attachment to tower structure, though high winds would create forces that exceeded design specifications for climbing equipment. Climbing rope offered additional security, but 80 miles per hour winds could make rope handling difficult and potentially dangerous during equipment management. Jackson's repair equipment included specialized tools required for satellite maintenance, replacement electronic components that could restore communication capability, and diagnostic equipment that would enable accurate assessment of damage and repair requirements at the tower's summit, where precision work would be challenged by weather exposure. Weather protection consisted of standard military cold weather gear that wasn't designed for extended exposure at 200-meter altitude, where wind chill effects would create apparent temperatures approaching -60 degrees Fahrenheit. Jackson understood that exposure time would be critical for preventing hypothermia and frostbite during repair operations. Communication equipment would enable coordination with base operations during climbing and repair activities, though high winds might interfere with radio transmission, and electronic equipment could malfunction due to cold exposure and moisture from precipitation and condensation. Jackson studied tower structural drawings and maintenance procedures while preparing for climbing operations that would test every aspect of his technical knowledge and physical capability. The tower's design included maintenance platforms and equipment access points, but reaching them required sustained climbing through conditions that challenged human endurance. Physical preparation included consuming high-energy foods that would fuel extended physical exertion in cold conditions, hydrating to prevent dehydration that could impair judgment and physical performance, and stretching exercises that would prepare muscles for sustained climbing operations under equipment loads. At 0815 hours, Jackson began his ascent of the communication tower as enemy forces continued advancing toward assault positions. Every minute of delay increased the probability that communication restoration would be completed too late to enable defensive coordination that could save 800 American lives. Jackson's initial climbing progress was immediately challenged by wind forces that threatened to tear him from the tower structure while carrying equipment that affected his balance and center of gravity during movement through increasingly difficult climbing conditions as altitude increased and weather exposure intensified. The 30-pound repair kit created additional challenges as tools and replacement components shifted within the pack, affecting his climbing rhythm and requiring constant adjustment to maintain proper weight distribution. The tower's structural design enabled climbing through maintenance ladders and platforms positioned every 25 meters, but high winds created oscillation that made the entire structure sway unpredictably in patterns that exceeded design specifications. Jackson had to time his movements carefully to avoid being thrown from climbing positions by sudden structural movement combined with wind pressure that could generate forces equivalent to several hundred pounds of lateral pressure. At 25 meters altitude, Jackson encountered his first major challenge as wind speeds increased with elevation and the tower's natural frequency began resonating with wind patterns, creating harmonic vibration that made climbing extremely difficult. The metal ladder rungs became increasingly slippery due to ice formation, requiring careful grip management and slower climbing pace to prevent falls. Jackson's climbing technique required continuous adaptation as he learned to read wind patterns, anticipate tower movement, and secure his position during gusts that could exceed 100 miles per hour for brief periods. His military training had included basic climbing instruction, but nothing had prepared him for technical climbing under extreme weather conditions while carrying heavy equipment at dangerous altitudes. At 50 meters altitude, Jackson encountered ice accumulation on tower surfaces that made grip difficult and potentially dangerous as metal surfaces became coated with ice layers that could shatter and fall, creating additional hazards. The combination of ice and wind created conditions where each handhold required careful testing and verification before committing his weight to climbing holds that might fail under stress. Weather conditions continued deteriorating as Jackson climbed, with precipitation creating additional ice formation and reducing visibility to less than 50 feet. The combination of wind, cold, and reduced visibility created disorientation challenges that required Jackson to rely on his sense of touch and tower familiarity to maintain proper climbing direction and avoid dangerous climbing errors. Wind chill effects began affecting Jackson's physical capability as apparent temperature approached -45 degrees Fahrenheit due to altitude exposure and sustained wind speeds that exceeded protection capability of standard cold weather equipment designed for ground-level operations. His hands began losing sensation despite insulated gloves, making tool handling more difficult and increasing the risk of equipment failure that could compromise repair operations. Jackson implemented cold weather survival techniques learned during military training, including hand-warming exercises, clothing layer management, and breathing techniques that could maintain core body temperature and prevent hypothermia during extended exposure to extreme conditions. However, these techniques were designed for shorter exposure periods and might prove inadequate for extended climbing operations. At 75 meters altitude, Jackson reached the first major equipment platform where he could rest and assess his physical condition while checking equipment security and adjusting his climbing approach based on conditions encountered during the initial climbing phase. The platform provided temporary shelter from wind, but structural vibration remained problematic and rest time needed to be minimized due to time constraints. The equipment check revealed that some tools had shifted within his pack despite secure fastening, and several items showed signs of ice formation that could affect their functionality during repair operations. Jackson reorganized equipment while warming critical tools using body heat to ensure they would function properly when needed for satellite system repair. Jackson's physical assessment revealed early signs of cold stress, including reduced manual dexterity, muscle stiffness from cold exposure, and slight disorientation that could affect climbing safety during the remaining 125 meters of vertical ascent required to reach satellite equipment positioned at the tower summit. Jackson's climbing technique adapted to extreme conditions as he learned to anticipate tower movement, secure equipment against wind forces, and maintain climbing rhythm despite physical challenges that tested his endurance and determination throughout sustained vertical movement under equipment loads. At 100 meters altitude, Jackson paused at a maintenance platform to assess his physical condition and adjust equipment for the remaining climb to satellite equipment positioned at the tower's summit. Wind speeds had increased, and structural oscillation was becoming more pronounced as altitude reduced the tower's stability. Communication with base operations became intermittent due to wind interference with radio equipment, but Jackson maintained periodic contact that enabled tactical coordination and progress reporting during the climb that was proceeding more slowly than optimal due to safety requirements and weather challenges. Jackson's physical condition was being challenged by altitude effects, cold exposure, and sustained physical exertion that pushed his body beyond normal operational limits. However, his determination was sustained by awareness that 800 soldiers depended on his successful completion of communication repair operations. At 150 meters altitude, Jackson encountered the most challenging climbing conditions as wind speeds reached maximum intensity and tower oscillation created movement that made climbing extremely dangerous while carrying repair equipment essential for satellite system restoration. The final 50 meters of climbing required sustained effort through conditions that exceeded human capability under normal circumstances. Jackson's hands had lost significant sensation due to cold exposure, making grip strength inadequate for secure climbing while managing tools and equipment necessary for communication repair. Jackson implemented survival techniques learned during military training to maintain core body temperature and prevent complete loss of manual dexterity that would make repair operations impossible. He used body heat sharing between hands, warming techniques for tools, and clothing management that could preserve functionality despite extreme cold exposure. Tower structural challenges increased as altitude reduced stability and wind forces created dangerous oscillation that could throw Jackson from climbing positions if he failed to anticipate movement patterns and secure himself appropriately during the most difficult sections of the ascent. At 180 meters altitude, Jackson could observe enemy forces approaching their final assault positions, emphasizing the time pressure that required rapid completion of communication repair despite weather conditions that made precision work extremely difficult under equipment limitations and environmental challenges. Jackson's physical exhaustion was approaching critical levels as sustained climbing under extreme conditions had depleted his energy reserves while cold exposure threatened to impair his ability to perform precise electronic repair work that required manual dexterity and technical knowledge under time pressure. The final climbing section required Jackson to overcome equipment challenges, physical limitations, and environmental conditions that exceeded every training scenario while maintaining focus on the technical requirements that would determine whether 800 soldiers could coordinate defense against approaching enemy forces. At 200 meters altitude, Jackson reached the satellite equipment housing that contained communication systems requiring immediate repair to restore contact with command elements and support systems that could enable defensive operations and tactical coordination during the imminent battle. Jackson's assessment of satellite equipment revealed damage that exceeded initial estimates, requiring complex repair procedures using tools that were difficult to handle due to cold exposure and wind conditions that made precision work extremely challenging while enemy forces approached final assault positions with coordinated attack capability that could overwhelm American defenses without communication coordination. The satellite dish alignment system had suffered mechanical damage that required complete disassembly of the tracking mechanism, component replacement using parts stored in the equipment housing, and precise recalibration using specialized tools while exposed to weather conditions that made electronic work dangerous due to moisture, extreme cold, and wind that could interfere with delicate adjustment procedures requiring precision measurement and alignment. Primary damage included bent tracking arms that had been twisted by wind forces beyond repair tolerance, damaged servo motors that controlled dish positioning, and misaligned signal focusing components that required realignment using precision tools while working at extreme altitude where manual dexterity was compromised by cold exposure and altitude effects that made fine motor control extremely difficult. Signal amplification equipment had experienced multiple electronic component failures including circuit board damage from electromagnetic pulse effects generated by enemy electronic warfare, power supply component failure due to voltage fluctuations during the cyber attack, and cooling system malfunction that had allowed critical components to overheat before temperature protection systems could prevent damage. The electronic repair work required diagnostic testing using handheld equipment that functioned poorly in extreme cold, circuit board replacement using surface mount components that required steady hands and precision placement, and system integration testing that required functional verification while exposed to weather conditions that could damage sensitive electronic equipment during testing procedures. Jackson's repair work was complicated by tool handling difficulties as extreme cold made metal tools dangerous to touch with exposed skin. Precision work required manual dexterity that was being impaired by progressive hypothermia and frostbite affecting his hands and fingers, and time pressure that demanded rapid completion despite technical complexity that normally required hours of careful work in controlled conditions. The tool management challenge required Jackson to warm tools using body heat before use, work with heavily insulated gloves that reduced dexterity, and complete precision adjustments while experiencing muscle tremors and coordination problems caused by hypothermia that affected his ability to perform the precise movements required for electronic component installation and system calibration. Circuit board replacement required removing dozens of tiny screws using tools that were difficult to handle due to cold exposure, carefully extracting damaged components while wearing heavy gloves, and installing replacement parts while verifying proper connection and orientation using visual inspection that was challenged by reduced visibility and lighting conditions at extreme altitude. System calibration required precise adjustment of multiple parameters using digital controls that were difficult to operate with cold-impaired manual dexterity, verification of signal strength and quality using test equipment that functioned poorly in extreme conditions, and fine-tuning of alignment systems that required steady hands and precise movements while experiencing physical tremors and coordination problems. Weather conditions continued deteriorating during repair operations as wind speeds fluctuated between 85 to 95 miles per hour with gusts exceeding 100 miles per hour. Precipitation created additional moisture hazards for electronic equipment, and temperature continued dropping toward -30°F with wind chill effects that created apparent temperature approaching -70°F at the tower summit where Jackson worked without adequate shelter or protection. Jackson's repair procedures required constant adaptation to environmental challenges as moisture threatened electronic components during assembly, wind forces made handling small parts extremely difficult, and cold exposure reduced his manual dexterity to levels that barely enabled completion of technical work requiring precision and steady hand control for successful component installation. Time pressure increased dramatically as radio communications from base operations indicated that enemy forces were in final assault positions and beginning preliminary attacks designed to test defensive responses and identify weakness in American defensive coordination that could be exploited during the main assault phase that would determine survival for 800 soldiers depending on communication restoration. Jackson's technical expertise enabled him to prioritize critical repairs that could restore basic communication capability even if complete system restoration wasn't possible within available time constraints, focusing on essential functions that would enable defensive coordination while deferring non-critical system features that could be repaired later if time permitted after basic communication was restored. After 35 minutes of sustained repair work under impossible conditions that had pushed his technical skills and physical endurance beyond normal human limits, Jackson achieved restoration of primary satellite communication capability including basic voice communication, data transmission for tactical coordination, and emergency communication channels that would enable base operations to coordinate defense and request support during the enemy assault. Jackson's descent from the communication tower occurred under enemy fire as hostile forces had reached assault positions and begun coordinated attack that included targeting the communication facility as a strategic objective that could cripple American defensive capability if destroyed during initial phases of combat operations. Enemy sniper fire forced Jackson to implement evasive climbing techniques that prioritized survival over speed while maintaining equipment security and personal safety during vertical movement under direct fire from enemy marksmen who had identified the communication tower as critical infrastructure requiring elimination. The descent was complicated by combat stress, physical exhaustion from repair operations, and continued exposure to extreme weather conditions that had weakened Jackson's physical capability while enemy fire created additional psychological pressure that could affect judgment and climbing safety. Jackson's climbing technique adapted to combat conditions as he learned to anticipate enemy fire patterns, use tower structure for protection, and maintain rapid descent speed despite physical limitations and equipment handling requirements that challenged his coordination and endurance. At 100 meters altitude, Jackson encountered enemy fire that damaged climbing equipment and forced him to implement emergency descent procedures using backup safety systems while maintaining communication with base operations that were coordinating defensive fire to protect his position during the critical descent phase. Weather conditions continued affecting descent operations as wind speeds remained high and cold exposure continued reducing Jackson's physical capability, but enemy fire provided additional motivation to complete descent rapidly despite safety considerations that would normally require more careful climbing procedures. Jackson's determination was sustained by awareness that successful communication restoration had enabled base defensive coordination that was already proving effective in repelling enemy attack, validating his decision to accept extreme personal risk for mission completion that would save 800 American lives. Base defensive operations began coordinating air support requests, artillery fire missions, and tactical maneuvering that would have been impossible without satellite communication restored through Jackson's heroic repair mission completed under conditions that exceeded human capability and equipment design specifications. Jackson reached ground level as FOB Aurora's defensive operations achieved tactical success through coordinated fire support, airstrikes, and tactical maneuvering enabled by satellite communication that provided real-time coordination with supporting units throughout the region. Enemy forces encountered coordinated defense that exceeded their tactical planning and capability, resulting in significant casualties and tactical withdrawal under pressure from American air support and artillery fire that had been impossible without communication coordination restored through Jackson's tower repair mission. The communication restoration enabled medical evacuation coordination for wounded personnel, supply coordination for sustained operations, and intelligence coordination that provided tactical advantage throughout subsequent combat operations that eliminated enemy presence in the region. Jackson's successful completion of the impossible repair mission had multiplied into strategic success that affected combat operations throughout the area of operations, demonstrating how individual technical expertise and heroic determination could achieve results that exceeded tactical probability and operational assessment. Jackson received the Distinguished Flying Cross recognizing his extraordinary technical achievement and courage under conditions that exceeded normal operational capability. The citation emphasized his technical expertise, personal courage, and successful mission completion that had enabled defensive success and saved 800 American lives. More importantly for Jackson personally, every soldier at FOB Aurora understood that their survival had resulted from one technician's refusal to accept that extreme weather made equipment repair impossible when lives depended on communication capability that could only be restored through individual technical expertise and heroic effort. Jackson's repair techniques and climbing procedures became case study material for military technical training, demonstrating individual capability and innovative problem-solving that could overcome circumstances that appeared impossible according to conventional technical assessment and safety protocols. The communication systems restored by Jackson continued providing reliable service throughout subsequent operations, validating his repair work and technical expertise while supporting ongoing military operations that benefited from the communication capability he had restored under impossible conditions. Jackson continued serving in communication roles while training other technicians in emergency procedures and technical innovation that could save lives when standard approaches proved inadequate for mission completion under extreme circumstances that required extraordinary individual effort and technical expertise. Jackson understood that his repair mission had demonstrated the practical meaning of military technical service, providing essential capability through individual commitment that exceeded personal safety considerations when soldiers depended on technical expertise for survival and mission success during combat operations. And that's Tech Specialist Jackson's Satellite Guardian story, the technician who climbed into hell to save 800 soldiers. Here at Last Signal Stories, we honor every technical specialist who risks everything to keep the lifelines operational. If this story of technical courage, determination, and never giving up moved you, hit subscribe for more military stories. Drop a comment below, would you have made that climb like Jackson? Until next time, stay tuned for the signal.